Alright, let's take a look at how to use the t-statistic and perform your calculations on a homework problem like number 15. Essentially the process is the same using Minitab. I've already gone ahead and shown the completed problem, even though you can't do that, but I just wanted to go ahead and have these answers here so that you would see how they match up. Another video shows you how to select and write your hypotheses, null and alternative. In this case, you want to test this claim that the environmentalist estimates that the mean waste recycled by adults in the country is more than 1 pound per person per day. So you want to test that claim. That's the claim that the mean is more than 1 pound per person per day. So you did a sample and you found that the mean waste for a sample of 10 adults is 2 pounds and the standard deviation is 0.4 pounds. At alpha equal 0.01, you support the claim, assume the population is normally distributed. Okay, so the reason we use t is because n is only 10. It's less than 30, so we're going to use t. That's how we know we use t. If n is less than 30, then we use the t distribution. So we've set up our null and our alternative, and again we go to the same place that we went before in Minitab. We go under Stat, Basic Stat, come down now to one sample t. Again, I've already got some information in here, so I'm going to get that out of there. Actually, I think it might even been the information from this problem. That's okay. I'll take it out just so you can see it being put in. So in this case, we have summarized data. We would only use sample data in columns if we had information in the columns, but it's already summarized. So our sample size is 10. The mean of that sample, not the mean of the population, the mean of that sample was, let's see, 2. And that standard deviation was given as 0.4. So then we want to tell Minitab that we're doing a hypothesis test. And the hypothesized mean, now that's where your claim comes in. He claims that it's 1. And we go under options and we tell what the alternative is, which in this case is greater than. The confidence level, again, is given in like 90, 95, 80, whatever. But in the problem it's given to you as alpha of 0.01, so you need to do that conversion, in which it's just 1 minus alpha. Or 100 minus this value, so it would be 99, the other side of that percentage. So our confidence level is 99. We're going to click OK. Click OK again. And here are all of your values. So you've got your t-statistic down here. The standardized test statistic is 7.91, and that is what my stat lab wanted. Here it is down here. And here is, let's see, I think that's all you needed. You did want your critical value of 2.821, which again, Minitab will do for you and I'll show you, but here's your p-value had you been doing the p-value approach. To get your critical value, again, this is your bound. You know that it's going to be a right tail because your alternative is a greater than, and you can just, an easy trick, just know that because it's the greater than symbol, it's pointing to the right. That's how you know it's a right tail. You can go under probability distribution plot, view probability, click OK. You need to change the distribution. Normally it opens up under normal, but you need to change it to t because that's what you're using. If you don't change it to t, it's not going to give you the right information. It's going to ask you for degrees of freedom, and that's just essentially asking you how much are you willing to vary after the test statistic has been calculated. But degrees of freedom are n minus 1. So it's 10 adults, 10 is n, so it's going to be 9. And then you need to tell it what direction your alternative is. So it's the right tail, we've already said that. And your probability is alpha, which is given as 0.01. Click OK. And there is your critical value of 2.821. So there it is. So then you are checking to see if your test statistic is in the rejection region or not. So 7.91 would definitely be in that rejection region. It would definitely be over there in the red. So we would reject the null. And then you could use the flowchart to write your final conclusion in the context of the original problem.